Did you know that each of us throws away, on average, more than 11 kilos of clothing per year? And that most of that clothing is not recycled but ends up in landfills or incinerated? We live in a fast paced society where the textile industry has become one of the most polluting on the planet, responsible for 20% of wastewater and 10% of carbon emissions. In Europe alone, we generate more than 12 million tons of textile waste per year and recycle only 22%. My thesis seeks to respond to this problem by developing a new composite material from recycled denim and a bio based matrix made from natural ingredients such as artichoke, pita, and hemp. The aim is to reintroduce this textile waste into the production chain by designing industrial applications that promote the circular economy. During the first year, I focused on constructing and characterizing the material. We test its resistance, permeability, behavior in the face of heat, adaptability to molds, and rigidity. The samples of recycled denim with clothing showed better initial structural behavior. On the other hand, the samples with beeswax stood out for their high adaptability, watertightness, and dimensional stability, making them ideal for semi rigid applications. Finally, we observed that when combining gluten with beeswax, the material offers excellent watertightness and thermal stability compared to test tubes made of algae or cork, which have higher absorption. The second year, the tests are focusing on exploring advanced functional properties, such as electrical conductivity. Through the integration of conductive threads with which the material is sewn, inks of different compositions to design external circuits, or graphene, which is included in the composition itself, generating a fully conductive material. Based on the conclusions drawn last year, six of the test tubes have been eliminated, and testing has continued only with those containing denim, gluten, diatomaceous earth, and beeswax. This conductivity test opens the door to new technological applications for these recycled and sustainable materials. Once the material has been characterized, application methods will be proposed based on material driven design methodology, which promotes that design of meaningful experience through materials. Because there are many composite material, but with this circular spirit and this vocation for metamorphosis, there are very few. As Antoine Lavoisier said, in nature, nothing is lost, nothing is created, everything is transformed. And transforming waste into resources is no longer just a necessity, it is an opportunity to redesign our future. Thank you very much for your attention.